approximately you think we are under, below, or above the unconformity? Someone said below. Anyone above? All right, it's unanimous. Why do you think we are below? It's more like it. Okay. Can you give more details what's right there?
The foliation. There is the sandstone.
Okay, so some already pointed out this rock has a cleavage. So we are under in the Wodonga bed. These are former mudstones that have been metamorphosed, and they had the penetrative cleavage throughout. So penetrative means that it's everywhere. Okay, we cannot see cleavage in one area, and then no more cleavage, and then cleavage again. No, cleavage is everywhere. It's called penetrative cleavage. Okay. Now here we see something else. We see the relationship of that cleavage with what might have caused it. So what may cause a cleavage is deformation. Okay, so basically this rock was metamorphosed, but it was also deformed. So you have a direction of space where the rock is being squeezed, okay? And then you have other directions of space where it is squeezed less. And that will control the orientation of the deformation structure you get. Depending on the pressure, temperature, which is a function of depth, you may get folding. And when you fold the rock, you can create a foliation in it. Okay? So basically all the minerals have a particular habit. And that habit will orient itself perpendicular to the direction of principal compression. So page 69, you have a sketch of the relationship between a fold and a cleavage that would be created in a fold. Okay, so what you see is that if the cleavage is created by the fold, then the cleavage should be sub-parallel to the axial plane of the fold. The axial plane is a mirroring plane of the fold. It's a very important feature to describe the orientation and geometry of a fold. So here we have access to just that on the outcrop. If we look right here, it's a little bit messy. It's hard to figure out exactly what is bedding, what is cleavage. We see clearly a foliation that seems to be going this way. What else do you see behind us in this direction? What do you see? No? No guess? Is there a compositional variation that we see in the rock?
Foliation starts and stops.
Foliation starts and stops. Maybe we're just too far away to see the foliation properly. But look at the compositional variation. If I'm here, you see a whitish layer, darker layer, a gray layer, brown layer, and they're alternating. Yes? So we have changes in color. We have changes in strength of the rock and or brittleness of the rock and how fluids are percolated through it. This is bedding because you had deposited different materials. If you deposit sand and then mud, if you metamorphose everything, you still have something that was previously sand and something that was previously mud. It will not become the same thing until the deformation is extremely large. So the deformation here was significant, but not sufficient to obliterate bedding. We still can see bedding, a compositional variation. Now, this bedding, if I am to represent its orientation, I would say it is something like this. So you can often take a planar structure like your booklet or whiteboard to extend what you see from the outcrop and visualize the attitude of the planar feature. So this would be the planar feature that I call bedding. Okay? Now we were saying that there is a foliation throughout the rock that is not bedding, because we're in the Wodonga bed. It is something like this. Now, from this cut of the rock, it is difficult to say if it's like that, or like that, or like that. I can't tell you. What I know is that the intersection of the plane of the foliation with the surface of the rock gives this orientation. Okay? To figure out, I need to look in this cut. Okay, if I look here, I should be able to pinpoint the orientation of the cleavage. So not only I have the strike, but now I can get the V. Now, okay. Yeah? Yeah, I'm on the wrong side to see it actually. So you need to look at different cuts of the rock to figure out the orientation of the foliation. But then you can just take the compass and measure. Now, in the afternoon we're going to learn how to measure strike and dip on rocks that have been folded. What I would like to do at this point is not so much focus on measuring the orientation of bedding and foliation, although we will do that quickly. What I would like to point out is the relationship between bedding and foliation. If I go back to page 69, you have a sketch of the fold and the cleavage. And here we have folds, and we see that they are not parallel with each other. Okay? Now if you look at that sketch, page 69, you can see that the relationship between the cleavage and the bedding is the surface that defines the fold. We can see that the angle will be very different in different parts of the fold. So where would the bedding and cleavage be at the same angle or the smallest angle? Is it in the hinge or is it in the limb of the fold? In the limb, okay? In the hinge, they become more and more orthogonal. And if you find them orthogonal, then you have figured out the hinge. So it's an important feature because sometimes you don't have access to the whole fold. Sometimes all you see is bedding and cleavage. And you have only a small part of it. So if I hide everything but a little patch on that sketch, can I reconstruct the fold? In many cases, yes. You have to figure out the relative angle between cleavage and bedding. So you measure the orientation of cleavage, you measure the orientation of bedding, you figure out whether you're in a limb or in a hinge. But there is one more thing that you need to figure out. To do that, you need to figure out which way the rocks are younging. Now yesterday, you've seen sedimentary rocks. Which way were the rocks younging? Up, right? In a sedimentary basin, it's pretty obvious the rocks are younging upward. Now these are sedimentary rocks. They used to be mid-sedimentary rocks, so there is a direction these rocks were younging. But it's been deformed. The bedding is not horizontal anymore. Can we say which way the rocks are younging? Well, this is where you need to not put structural geology and sedimentology in different compartments. You need to apply everything you know about sedimentary rocks to deform sedimentary rocks as well. Okay? All the features that you saw yesterday in the sedimentary rocks, we could try to find them here. Many of them will have been erased, but if some are preserved, you will be able to figure out younging, which way was up before the deformation. Okay? And that's important. Yeah, you can figure out the deposition environment as well, but you can use sedimentology for not just figuring out the deposition environment, but also as a tool to unravel the deformation. Without an indication of how these rocks were deposited, we would not be able to unravel the folding. So all the deformation that comes after, it is linked to how these rocks were formed. Okay, so now I'm going to go back to what is the task that you have to do. What page is that? 26. You have to sketch this outcrop. So here we want to sketch the rock platform here. Okay, so instead of the top of your diagram being up and the bottom being down, your sketch is a map view. Everything is at sea level. Okay, up is this way, down is that way. So what we need in here is a north arrow. Okay, and then you need to sketch the position of bedding and cleavage in this area. And before you do that, I want to show you what bedding does. So everyone okay with the bedding being like this? Yes? What's happening to it? You can see where wheel is. It comes all the way here. Okay? Roughly in a similar position. And then what's happening right where we stand? Well, if we follow the bedding, we see it turning here. Okay? See the bedding coming here, it comes and it turns. So what part of the fold is that? It's a hinge. Okay, we have bedding. You can sketch the bedding coming from out there, coming all the way here and turning. And therefore, if you stand right here, you are in the center of the fold, in the axial plane. The axial plane is somewhere like this. And I can see the bedding coming here and turning this way. Okay, so let's try to sketch the relationship between the bedding that does this and the foliation that remains more or less constant throughout the fold. And then think about, does this foliation, is it parallel to the mirroring axis of that fold? If that is the case, then that indicates that this fold that we see is the one that caused the cleavage. The formation does not always include only one folding event. Your rocks can be deformed and then deformed again and then deformed again. And these are much older than the Sydney Basin. So chances are these rocks may have been deformed many times. So it is possible that the fold we see is not the one that is associated with the foliation. The way to test that is whether the foliation and the axial plane are parallel. If they are parallel, then we are in the simple case. Okay? And then Al and I will show you how to measure strike and dip for bedding and foliation. So you can sketch the outline of bedding, sketch the orientation of the foliation, and in the sketch, right in there, you're going to make the trace of bedding and the foliation in the proper orientation, and you can put a symbol for the strike and dip of bedding and foliation. Now, there are different symbols that can be used for this. So let's say we have a fold that does this. That is our bedding. Okay? The bedding is named S0. Why is it? Because it's the primary foliation. Okay? It is the first foliation that you can have in the fold, because that's the one that makes the rock before the fold. Okay? And then you have the axial plane, and if you have an axial plane of cleavage, a cleavage that is caused by the folding, it will be subparallel, like this. Okay? The first one you see is called S1. If you see another one, it would be called S2. And then so on.
So I think an S is a surface.
S is a surface. The first surface is not S1, it's S0. Okay? And usually, if this is a fold that has an axial plane of cleavage that we call S1, then I would call that one F1. Okay? One folding event causing one foliation, all with the same number. Okay? So if you have more than one event, we know what we're talking about. Now, if you have an S1 or an F1, it doesn't mean it's the first it means it is the first you can see. When you have more than one episode of deformation, you may erase entirely the previous event. Usually you don't erase completely, but you may miss the clues that indicates that there was a previous event. In which case you need to revise your interpretation, rename all your folding events. Okay, so on a sketch like this, you would put a symbol like this for bedding. It has a long bar that is the strike of bedding. On my sketch, the long bar will be parallel to the trace of my fold. Okay, so if I put one here, it will still be parallel. If I put one here, it will still be parallel. And then the little tick indicates which way bedding is dipping. Okay, and then you put only one number. The number you put is the dip. You don't need to put the number of the strike because the orientation of the long axis of the symbol is already the value of the strike. Okay? For the foliation, you use similar symbol. It has a long axis, but instead of a tick, it has a little triangle that indicates which way it's dipping. I think there's also symbols with ticks at the end, but this is a fairly common symbol for foliation. And again, you give only one value, which is the dip. You don't need to tell me if it's dipping east, west, north, south, because the figure has an orientation. So your symbol is already telling me here that it's dipping to the west by 80 degrees, and it's already telling me that this is the strike. So you don't need to put these numbers on the map. We try to put as little symbols as possible on the map. Okay? However, in your notes, you need to write that you have bedding, and then you need to write the strike between 0 and 180. You need to keep it 3 digits, slash, and then the dip between 0 and 90 degrees, and then the quadrant. Okay? North, south, west, east, whatever. This indicates precisely the strike and the dip, and it is not ambiguous. Okay? So here we use this convention. It's a strike between 0 and 180 degrees. Elsewhere you may find that the strike can be given between 0 and 360. If that's the case, you don't need the quadrant. And then you use what is called the right hand rule. Your thumb is the strike and all the other fingers are the dip. Okay? So just at the moment, keep in mind that there are different conventions, but at this point we would like you to use all this convention. Strike between 0 and 180, dip between 0 and 90, 0 being horizontal, and a quadrant. And in your notes, you would do exactly the same for the foliation. Okay? It's a planar feature, so it has a strike and a dip. And this afternoon we'll see that when you have two planar features like this, they intersect, and when they intersect you don't have a planar feature anymore, you have a lineation. And it is, we're going to write it in a very different way, but we're going to learn one thing at a time. Okay? So let's now practice measuring strike and dip. You can use this board for your sketch first.
I like that.
Yeah, just, sketch from a couple of meters back here, and this hinge, that's the extent of what you want to sketch. So keep in mind to have something like this with an orientation, with the trace of S0 and S1. What else do you need on the sketch that is not here? Scale. You need a scale. Okay?